Blinding the data. Well, that's chapter 4 stuff. Blinded clinical trials. That's not in today's section, but it'll be in section coming up real soon. It'll be in chapter 4. But that's what I was doing. Instead of grading your tests, I was working on freshly unblinded data. So you do the first analysis of the data, and you can tell the company whether the trial was a success or not. And unfortunately, this trial was not a success. But we got to looking at the data. It's a very small study, only had about 6 or 7 patients per treatment group. And we found a data error. Wednesday afternoon, we found a data error that we had to go back and fix. And it was kind of interesting. I showed you at the beginning of the semester about cleaning data. Well, these were something called titer levels in the blood. So you draw blood and you check titer levels. If you were a nursing student, maybe you've heard of this kind of thing. But we had one patient whose baseline reading came in as that. And the software said, well, that's not numerical data. And it kicked it out, called it a missing value. Well, the clinical person on the trial said, well, everybody had a baseline. I know everybody had a baseline. So we went back and I did a lot of digging and I found this value in the source document, which our system had converted to a missing value. So when we went back and replaced that with a 24, what it meant was below detection limit. Right? It was less than 24, and 24 is the minimum value that we can detect. So we went back and we put it in as a 24 because that was the conservative thing to do. And lo and behold, now they had statistically significant differences between their treatment groups. So it made a huge difference, just one with the patient. So, but what that meant was I had to spend Wednesday evening and all day Thursday rerunning 30-some tables and rewriting the. So that's what I was doing instead of grading your test. So, excuses. That's really related to this section or this whole chapter, because this whole chapter is about design of experiments. So it's all those things I was just talking about: blinded studies, control groups, statistically significant differences, all those kinds of things. So that's what we're going to be talking about. The syllabus for today says that I'll be covering 4.1 and 4.2, but in my previous class this morning I was not able to get through 4.2, so I'll probably only get through 4.1, and maybe I'll get partway through it. But remember, homework's never due until after I completely finish a section, so you'll only have for Monday probably the 4.1 homework, unless a miracle occurs and I get all the way through it. But we'll catch back up, don't worry. We'll catch back up to the syllabus. That's the way it works. So remember, early in like chapter 1, we talked about there's 3 kind of areas of statistics. There's descriptive statistics, there's inferential statistics, and there's design. Do you remember what design is? What is that referring to?
Design of the study.
What's that?
How the study is made.
Exactly. How the study is conducted. How is the data collected? Anything that has to do with how data is collected is said to be part of the design of the trial. So the trial I was just involved with this week, I said it was small, 6 or 7 patients per group. There were 3 treatment groups. They were studied for 33 days each. All that's part of the design of the study. I said it was a blinded study, everything, all that stuff. It had a placebo group, which again, that's later in chapter 4 to define what placebo is, but just in a nutshell, what is placebo? Do you know what that means?
Sugar pill versus actual drug.
Okay. People always say it's a sugar pill. Technically, it's not a sugar pill, but it's a sham treatment that's supposed to look, taste, and smell exactly like the active medication, the one that actually has the drug in it. We'll talk about that later on, but that's part of the design of a trial. So let's start off with a couple of different terms that you're going to have to know. The first one, there's 3 types of main designs or studies. First one is anecdotal, and then observational, and experimental. And these are written kind of in the order of quality. The least quality type study is called anecdotal. It's anecdotal evidence. Now what the heck does that mean? Have you heard the word anecdote?
Yep.
You ever know anybody that was good at telling anecdotes? Right? They're kind of like little stories that you tell, right? Well, anecdotal evidence basically is a story someone's telling about a single subject. Whether it's a person or, you know, everything that I do seems to be health related because that's my background, but you know, you might see something where a physician says, well, I had this patient who came in with these symptoms, and here's what I tried, and whoo, they got better. That's anecdotal evidence, right? You can't put a lot of stock in that kind of evidence because there's a lot of things that could have accounted for that reaction that don't have to do with the treatment. But after you compile enough anecdotal evidence, you might say, well, it looks like there's a trend here. So maybe we should do a study, a full-blown study. Okay? Here's a great example of anecdotal evidence. One of my office mates in graduate school grew up close to where I did. He grew up in the northwestern part of Missouri, and I grew up in northeast Kansas. But his dad was a cattle farmer, and he's one of those good old boys from the farm. And he would always say, if I'm ever in a car accident, I don't want my seatbelt on, because I want to be thrown clear. Because I know this guy, here comes the anecdote, I know this guy who got in a car accident, got trapped by his seatbelt, couldn't get out, and burned to death. So I want to be thrown clear. Now, how much statistical evidence do you think there is that wearing a seatbelt dramatically improves your chance of survival in an automobile accident? Lots and lots. But he's got a sample of size 1, that yeah, there's always going to be some exceptions to the rule, but you know, we got to think statistically. We got to think, you know, what's the probability of survival? What's the proportion of people who survive? And those that aren't wearing a seatbelt are much less likely. So anecdotal evidence, you can't put a lot of faith in that. Okay? The next level is observational. So an observational study is just that. It's a study where the researchers don't try to change anything. They just let people do what they've been doing, and they observe them. Right? I've observed that those people who start smoking and smoke their whole life have a much elevated risk of lung cancer. But it's observational. The third kind is experimental, and this is the highest level of quality. This is kind of the gold standard type of study. Experimental, the researcher assigns, I'll put it in quote, groups or treatments. Now the word treatment comes from the medical field, but it's commonly used in statistics. It doesn't necessarily mean that you're giving some kind of treatment, but it's kind of a generic word. So I might be interested in studying the effects of exercise on cholesterol. Well, exercise is the treatment, or the people who exercise is that group. In an experiment, the researcher decides who goes into what group. In an observational study, the subjects decide. They were just already doing that. Okay? So here's a little example. Suppose I'm interested in studying the relationship between exercise and cholesterol. So I had a statistics course once back in college. So I know I had to do a study then. I can't just talk to my dad who exercises, right, and get anecdotal evidence. I need to do a study. So I go down here to the Student Wellness and Recreation Center, and I find 50 people who are exercising in there, who are willing to be in my study. So the next day I bring them over here to the health center down here in Morgan, and I have them draw a little bit of blood, and I check their cholesterol levels. And I think, okay, now I need to get a control group. I need to get some people who don't exercise. So let's see. I'm going to go down to the McDonald's down here on the corner, and I'm going to recruit 50 people who are in there eating dinner, and they're not exercising. All right? So I ask them, do you exercise, yes or no? If they say no, then hey, you want to be in my study? And then I draw their blood, and I get their cholesterol levels. And lo and behold, when I analyze the data, the average cholesterol in my exercise group is significantly lower than the average cholesterol in my non-exercise group. Good design, bad design.
Horrible.
Horrible.
Cool.
Yeah, it is. What's wrong with that? First of all, is that an observational study or is that an experiment?
Observational, you didn't do anything to them, you just asked them.
Yeah, it is observational. I did not do anything to change their behavior, right? What I usually say is the researcher assigns groups. Another way to say that is you impose the treatment in an experiment. So that's in an experiment. In an observational study, you don't impose the treatments, they decided for themselves. And that's the case that I just described. Those people were already down there exercising. Those people were already at McDonald's, and I asked them, do you exercise? They said no. So they decided whether they were in my exercise group or my non-exercise group. Okay, so that's an observational study. What's wrong with an observational study? Why is it not as good as an experiment? There could be lurking variables. Excellent. It's like a pater to say that right there. Can you name a lurking variable in my cholesterol study?
Well, people from being
Diet. Yeah, that's the big one. Diet, right? And I purposely put it in McDonald's to tip you off on that, right? If they're in McDonald's eating dinner, they're eating hamburgers and French fries, and that is already known not to be the best thing for your cholesterol level, right? So when I say, look, the average cholesterol is lower in my exercise group, that does not necessarily mean that exercise caused the lower cholesterol. Remember chapter 3? Causation and correlation. Correlation does not imply causation. There could be some other explanation, like their diet. Okay? So let's fix it. Design me an experiment. Try to control for lurking variables. Diet, among other things.
Take 50 students out of the class and you tell half of them, you take their initial cholesterol, then you tell half of them to regularly exercise and stuff, and then the other ones don't exercise, and then take the blood again after to see the cholesterol.
Okay, excellent. She said take 50 students and randomize. You didn't say random, right?
Yeah, I just said.
Yeah.
I'm
And we'll learn in a little while that randomization is the best way to assign the treatments. To be an experiment, it doesn't have to be randomly assigned, but most good experiments are. But we randomly assign half of them to start exercising, the other half to not exercise. And then you incorporated something new that I didn't talk about, a baseline measurement of cholesterol. Right? Because it could be that even at baseline, one group, just by random chance, had higher cholesterol than the other group. So it could make it look like there's a difference. So we do a baseline, and then we do change from baseline as our response variable instead of just cholesterol. Right? Very good. Yeah?
Well, could you also ask them if they had high cholesterol run in their family? Because you don't get cholesterol just from the food you eat. You get it from your family heritage, I guess.
Yeah. I've seen that commercial too, where they had the guys dressed up like bacon and eggs and all that stuff. So yeah, there's definitely a hereditary aspect to cholesterol, so you would want to control for that somehow. So one way to control is to ask them about it, and then you can put it in the analysis at the end. And that's a little more sophisticated than what we'll get to this semester. But you could do things as simple as what's called stratification. You can say, well, let's get those who have a family history of high cholesterol, randomize half of them to each treatment group, and then take those who don't have family history and randomize each of them to both, or half of them to each treatment group. So I don't, by luck of the draw, get most of my family histories in one group and most of the non-family histories in the other group. I force it to be balanced that way. So that's a good design. Anything else? Nobody mentioned diet. Diet's a lurking variable. How are we going to control diet?
Yeah, keep them on the same nutrition, I guess.
Keep both groups, the exercise group and the non-exercise group, you tell them what they're going to eat. Okay, here's your diet for the next 6 weeks or whatever it is. Right? So you control the diet. You make sure that one group isn't eating McDonald's and the other group eating, what's a good one? Subway? At least Jared tells us it's a good one. Right? So control the diet. So an experiment, the researcher has close control over every lurking variable that they can think of. Now, you can't think of them all. But if you randomize to the groups, the randomization helps control for lurking variables that you didn't even think of, because it will tend to balance them out and put half of them in one group and half in the other group. Whereas if you let the patients decide what group they're going to be in, there's all kinds of lurking variables that could go along with that. Yeah?
Wouldn't adding in the diet control sort of add another factor to it? Because if they had a really poor diet beforehand, and then you change them to a much more healthy diet, you don't know if their cholesterol is changing because of the effects of the diet or the exercise.
Yeah, that's a great point. You'd have to sort that through. That's the kind of thinking I want you guys to get used to doing, is that, well, if I put them on a healthy diet, then those that were on an unhealthy diet, now their cholesterol got better, even though they were in the non-exercise group, right? So we want to do something to account for that, right? So, yeah.
Those in the exercise group, though, theirs should still improve above and beyond the people who just changed their diet.
Yeah, that's true. If the
Because
effect,
if you flatline the diet for everybody,
yeah,
and then you have the one group doing the exercise, there would
But-
still be a difference.
right. But there is going to be an extra source of variability there caused by that we're going to have to account for. So, okay, all right. Let me pull the screen down, and I've got some articles to discuss. The first thing is not an article, but I want to show this to you. Oh, I guess you can't see it. I used to think correlation implied causation. Then I took a statistics class. Now I don't know. Sounds like the class helped. Well, maybe. It's one of those kind of out there jokes, isn't it? It's the theme of correlation does not imply causation. He used to think it did, but then he took, and now she's saying, oh, then there's a correlation between taking a statistics class and changing your mind on that. Well, I can't say for sure it was a statistics class because that would imply causation. See, it gets it twice in there. See that?
Did you do that yourself?
It's not that bad, is it? No, I didn't do it myself. I had a student that sent me that. All right, now let's look at this. One of the things I like to do in this class, and I appreciate when students do this, is if you see like a newspaper article or you hear it on the radio or something like that, and you're a little bit skeptical about the results, bring it in. Let's discuss it. You know, one of the things that happens in a class like this is most people come into the class thinking about research and things that get published. Well, if they said it on the news, by golly, it's got to be true. And then after you take the class, the pendulum goes all the way the other way. All research is crap. Well, it's a happy medium in there somewhere, right? Some research is crap and some is really good, and it all gets reported. So you got to sort it out yourself. So one of the things I want you to learn is how to decide, and by looking at these three things, that's a big part of it. Was this a randomized experiment or was it an observational study? If it was observational, then you're not going to give it quite as strong of approval, right? If it's anecdotal evidence, Probably not. What this says is using Facebook can lower exam results by up to 20%. Let me see if I can blow that up just a little bit without.
Revise in front of the computer?
Yeah, they revised their Facebook page.
No.
This was a study that was done, and by the way, always consider your source. Did you hear this on the evening news, or did you get it out of a scientific journal? Right? A journal's a better source of information. This I got off of somebody's blog. Somebody that I never even heard of, right? It just, I saw the thing off on the margin of a web page or something. Study shows using Facebook can hurt your exam scores. Ooh, that'd be good for class. So I went out and looked at it. Somebody's blog. So here you go. But he does quote a study, an actual study that was done. Second line says, students who use Facebook while they study get significantly lower grades than those who do not, according to psychologists. Now, I like this because I'm a parent of teenagers, and I have a son who can hold his cell phone in his left hand, he's right-handed, send a text message without even looking at the phone, looking at me going, I'm listening, yeah. And he says, well, I'm multitasking. And I say, bull crap. Multitasking is another word for not doing anything very well. Right? And I've been saying that for years, and here it is, in black and white. Right? It says, that exam results of those who used the social networking site while working, even if it was on in the background, were 20% lower than those for non-users. Okay? Our study and other previous work suggest that while people may think constant task switching allows them to get more done in less time, the reality is it extends the amount of time needed to carry out tasks and leads to more mistakes. And I wholeheartedly believe that to be true. What kind of a study was it? Well, it says his team studied 219 students aged between 19 and 54 at an American university. The Facebook users among them had a typical grade point average of 3.06. Not bad. Non-users had an average GPA of 3.82. Really good. That's all this says about the design of the study. Experiment or observational? Observational. It's an observational study. How would you have to do an experiment of Facebook and exam results?
You have to have the constant GPA and then force people not to use it and force people to use it.
Okay. Control for GPA. Okay. And you might not have to have a constant GPA, but at least divide into groups. That those that are within so much of 3.0, and so much of 3.5, and so much of 4.0, let's look at results separately within those. You know, control for that Simpson's paradox thing, right? But then you say force them to use Facebook or keep them from using Facebook while they study. You know, you say, you're in the Facebook group, you're not in the Facebook group, right? Well, you can think that that might actually be hard to pull off as an experiment. Because if somebody's a non-Facebook user, like me, I'm old, I don't use Facebook. Although my mother-in-law uses Facebook more than my daughter does. But anyway, that's not what I'm here to talk about. It's hard to force somebody who doesn't use Facebook, I want you to use Facebook, because they don't have a friend network out there all set up, so they're not going to be as distracted by it, right? And I suspect it'd be really hard to somebody who's addicted to Facebook to tell them, now don't be using it the next week, okay? Okay. And they're going to be non-compliant with the treatment, right? But can you think of any lurking variables? Since this is observational, you have to think about lurking variables. Can you think of lurking variables that might be related to both Facebook use and exam scores or GPA?
Age,
Okay, age. Okay.
what classes are teaching.
How does age affect grades?
Older people probably pay a lot more attention than the younger people and also don't use Facebook?
Okay, older people probably pay more attention. And I'll be honest, that's true. People who are going back to college are much more motivated because they already know what it's like to be in the real world without a college education, right? Those of you that are fresh out of high school, you're just like, hey, it's all easy, it's all wonderful. Right? But you'll learn. Okay, so that's one thing, age. Think of another one? You don't have to be politically correct. Who's less likely to be using Facebook? Remember, it's observational, so they're deciding which group they're in.
People without internet.
Okay, people without internet. I was going to say people without friends.
I was
Right?
gonna say, like,
It's a social network.
really smart people sometimes are bad at social networking in
Okay.
general.
That's the lurking variable I was hoping somebody would point out, right? It's the proverbial math geek,
Yeah.
right? They're studying all the time. They don't have a social network, so they're not going to be on Facebook, right? Definitely a lurking variable. Now, I don't know if that's really that true or not. I'm a statistician. I'm as social as they come, right? No, not really. But you can see how it might be related to that. And that's a lurking variable that if they didn't control for it, and here they don't give us any information whether they did or not, then I would be real suspicious about these results. But I'm not telling you it's okay to use Facebook while you study for your statistics exam. I'm just saying this article alone is not enough for me to convince you to change your behavior. So an observational study there. Let's see. Let's do this. Zinc nasal gel for the treatment of common cold symptoms, a double-blind, placebo-controlled trial. Here's the abstract. This is from a scientific journal. I don't remember which journal right off the top of my head, but it's probably down at the bottom. Yeah, Ear, Nose, and Throat Journal. And it's kind of hard to read because it's not a real clean copy, but in the abstract, a lot of times they'll tell you enough information in the abstract to know what the design of this study was. First of all, was this an experiment or was it an observational study? It says right here, 108 patients received zinc therapy, 105 received placebo. Actually, that didn't give me what I need, so I may have to go down into the materials and methods section. And almost all journal articles are set up similar. They'll start with an abstract, which is like an executive summary. Then they'll do an introduction. Then they'll do a methods section, tell you how they did the research. Then they'll have a results section. Then at the end, they'll have a discussion section. In here, in the methods section, right up here, the study population consisted of 213 subjects. They were randomly assigned to receive either zinc nasal gel or placebo. Experiment? Yeah, experiment. And this is actually a very good experiment. It's a randomized, placebo-controlled experiment. Now, you can have experiments that aren't all that good. Just because it's an experiment doesn't mean it's good. You can have an experiment that doesn't have a control group. Right? You can have an experiment where the physician decided who got which treatment, and he gave all the sick people the active medication and gave all the people who weren't so sick the placebo. That's an experiment, but it's a bad experiment. So just because it's an experiment doesn't mean it's necessarily good. Now, have you heard of Zicam? That's the gel they're talking about, zinc gel, right? Zicam. It was like a gel, and you squirted up your nose when you got the first sign of a cold, and it was shown clinically proven. Now, a statistician will say you can never prove, but you can say I'm 95% confident that it does decrease cold symptoms. So it's the proverbial cure for the common cold. The problem is that since this article was published, just in the last year, they yanked the nasal gel off the market. And you're nodding. How do you know why?
Well, my grandpa used to use it, and he can't taste anything anymore.
Oh. And that's why they pulled it off, because that people that used it a lot it was fairly rare, but it's, you know, all drugs have side effects. One of the side effects was that they lost their sense of smell, which taste, 90-some% of your taste is your smell. So if you lose your sense of smell, then you can taste salt, you can taste bitter, you can taste sweet, and that's about it.
That's what it said.
Yeah. And apparently it's real.
It
Right?
is.
And I used to use it a lot. As soon as I heard that, I'm like, I think I'll keep my nose. So you can still get Zicam, you just can't get the stuff you put up your nose. It's like tablets. So it's, you know, the nasal gel was worked the best because it's the rhinovirus. Rhino means nose. No, I thought it was an animal. Animal with a big nose. Right? So it's rhinovirus. It lives in your nose. So you're putting the zinc right there and killing the virus right there where it lives. Whereas if you take it systemically, it will kill the virus, but it's just not as effective. Yeah, it takes longer, it takes more of it. So. Okay, so we've seen an experiment, we've seen an observational study. Among observational studies, there are three main types of observational studies. One is called a case control study, which by definition is a retrospective study. And I'll come back and define that for you here in a little bit. Let me get them all written down. Then we have a cohort study, which not always but usually is a prospective study. And then we have what's known as a cross-sectional study. Okay, so the middle one here is a cohort study. So let me describe what a cohort study is, and then this is probably the most famous cohort study that's been going on in the United States. I'll talk about that one for a little bit. A cohort study means that you get a group of subjects, called a cohort, and you follow them through time. And you ask them regularly about different exposures or habits or whatever, and then you see what diseases develop. Right? So the Framingham Heart Study is a very interesting study. This is still going on today. They're actually in their third generation now. They've recruited the grandchildren of the original Framingham Heart Study to be in this study. It's been ongoing all this time. Started in 1948 in a town called Framingham, Massachusetts. And they just recruited, like, I think it was, it says in here somewhere, 5,209 men and women between the ages of 30 and 62 back in 1948. So 5,200 subjects, all from the same town, and they just followed them through time. You know, asked them every year they would come in, they'd have a lot of physical assessments done and blood draws and things, and look at all these different health characteristics, and then give them a fairly extensive survey on what are your dietary habits, what's your exercise habits, all these lifestyle kind of questions. And from that study have come much of what we now take for granted as known causes of heart disease and stroke and things like that. So it's a very important study. They did the second generation back in the mid-'80s. They recruited the children of the originals, and now they have, just in I think 2003, they recruited the grandchildren, and they just keep this thing going on. And so a lot of the original study are still there, and now they're pretty elderly, and they're coming in and still getting this extensive workup once a year. And so that's called a prospective study. You recruit them in the study, and then you follow them forward through time. Okay. A case control study, by contrast, is a study, well, let me see. I've got an example of a case control study here, I think. No, I don't see it get there. So let me read the one in the book. At the front of chapter 4, in front of every chapter in the book, there's an example. Right? It's like the chapter example. And this one is about cell phone use and cancer. Have you ever heard that using a cell phone too much could cause cancer? Or could it increase your risk of cancer? Well, as of today, the jury's kind of still out on that one. Some studies say there's a definite link. Some studies say we don't find a link. How could they differ? Lurking variables. A lot of these studies are observational studies. So one study controls for something and they show a difference, another study doesn't, they don't show a difference, or vice versa. Let me read the first one. They talk about 3 different studies. A German study compared 118 patients with a rare form of eye cancer called uveal melanoma to 475 healthy patients who did not have the eye cancer. The patient's cell phone use was measured using a questionnaire. The eye cancer patients used cell phones more often on the average. In other words, they established an association that more cell phone use, there was more cell phone use in the group that had cancer than in the group that did not have cancer. That is known as a case control study. It is observational, right? Case control. So what does the word case mean? You ever said you had a case of the flu? That's what a case is somebody with the disease. Okay? So the case is somebody who has the condition that you're interested in. And this study is recruited different than that other study. Because in that study, you just got people in there and you follow them through time and waited to see who developed the condition of it. Here, you recruit them by them having been diagnosed with this. Oh, you have eye cancer. You want to be in our study? And then you match them with controls who are known not to have the condition. So those are your controls. So you have the cases who are known to have the condition, controls who are known not to have the condition. Then you look backwards in time, retrospectively, to ask them about exposures to certain things, like cell phone use, or smoking, or whatever else, exercise. Okay? And if you find a difference in those 2 groups, then that's evidence that there's some kind of a association. It does not do a very good job of establishing causation. Because in a retrospective study, you can't be 100% sure that the cell phone use came before the cancer. Right? So it's really hard to establish cause and effect. A cohort study is better at establishing cause and effect, but still not as good as an experiment. A cross-sectional study is a study that is done at one point in time. You don't look forward, you don't look backward, you just say, okay, at this point in time, you have this condition, and you're doing this. And you look for an association. Okay? So that's called a cross-sectional study. Let me show an example that just popped up this morning. When I was preparing for this lecture, I wish I could get rid of some of this stuff and make that bigger, but
There's a proposed thing on the city document, survey document.
right there is. I don't know if I can get rid of that, but anyway, I won't waste time trying to do it. Is common cold making your kid fat? Right? What I said, I want to prepare for this lecture today, so I always like to bring in hot off the press stuff. So I went to CBS Health Watch website this morning. And here's a link to this study. It says September 22nd, 2010. So that was Wednesday, right? While you guys were sitting in here taking your exam, they were publishing this article about obesity in children. So let's look at it. It says, now I'll have to kind of read this because it's small. When it comes to childhood obesity epidemic, the message has been pretty clear. Cut the junk food and get the kids outside to move. but there may be a new culprit. Researchers at University of California, San Diego found that obese children were 3 times more likely to have been exposed to adenovirus 36, AD36, a common cause of some colds and respiratory and eye infections. So, what kind of a study is this? First of all, is it experimental or observational?
Observational.
Definitely observational. It'd be hard to do this as an experiment, wouldn't it? Recruit some kids to come to the study. Okay, now I'm going to expose you to this virus, and you guys I'm not going to expose, and then we're going to see who gets fat. Right? Not a very ethical study. While the adenovirus has been shown to increase the likelihood of obesity in animals and adult humans, this study is the first to establish a link in children. Still, outside experts warn that its findings are preliminary and that cause and effect, whether AD36 causes obesity or whether being overweight makes it easier to catch the virus, isn't clear. Cause and effect, you got to get the order right. Did they get the virus because they were obese, or did they get obese because they had the virus? This study can't show that. Somewhere in here, we've established that it's observational. Which one of these 3 is it? But we really haven't had quite enough information in just that to see. Oh, maybe I cut it off too soon. Oh, you know what? Right here, there's a link. It says, the findings were published in the journal Pediatrics. And I went out to the Pediatrics website. I don't know if I can get there quick enough. And I read the abstract. It wouldn't let me download the full article. Sometimes they will. Like it has a link here, full text PDF. But you try to download it, it says, oh, it's $30 and we'll let you download it. So I didn't do that. I think in here, they talk about the design of the study in a little more detail. Oh, there it is. Methods. Can you read that? A cross-sectional study of children 8 to 18 years of age was performed. Children were classified according to BMI percentile as non-obese if they were less than the 95th percentile. Remember percentiles? So they could still be have a higher BMI. BMI is body mass index, right? They could have a higher BMI than 95%, or at least 94%, and still be called non-obese. So they're taking the upper 5% of obesity, and then the presence of AD36 antibodies was assessed using a serum neutralization assay. A total of 124 children were studied. Of those children, 46 were non-obese and 54 were obese. So they did not recruit the patients based on whether they were obese or not. They just got a study of kids, and then they calculated their BMI and classified them obese, non-obese. Then they looked at whether they had this virus or not. They didn't go forward in time. They didn't go backward in time. It's cross-section. Okay? All right. Now, some homework problems. Here's one about cell phone use again. This is from the back of your section. This is problem number 4.2. You will have some online homework that are similar to these. They may change the wording a little bit, but a study identified nearly all cases in Sweden of acoustic neuroma, a benign tumor of the auditory nerve. It matched these subjects with others of similar age, gender, and residential area who did not have acoustic neuroma and compared the 2 groups on their mobile phone use. Was this an experimental or an observational study? Observation. Okay? Which type of observation? Cross-sectional?
Matching, cases to control the decouple, right?
This is a case control study. It's not real obvious that it isn't cross-sectional. I was reading back to see where the tip-off was, but it says a study identified nearly all cases of acoustic neuroma. So they said, okay, this person has acoustic neuroma, let's get them in the study. So they were identified as a case and then recruited into the study. So that's the hallmark of a case control study. Whereas a cross-sectional study, you just say, they would say something like, we took a random sample of 1,000 patients, this many had this neuroma, this many did not. So they wouldn't know it until they had them in the study. Yeah?
And then did it say they looked back at their cell phone use?
Well, it didn't quite say that. It said, and the two groups, and compared the two groups on their mobile phone use. Then it goes on to say, when considering tumors on the same side of the head as the phone was normally used, those with tumors were more likely to have used mobile phones for at least 10 years than those without tumors. So if I went on to read that, then it kind of says, that's retrospective. Because they've gone back, how long you've been using your cell phone. Explain why this does not prove that greater use of mobile phones causes subjects to be more likely to develop acoustic neuroma. Why does it not establish causation? That's always the answer, isn't it? Lurking variables. Now, I'm having trouble thinking up a potential lurking variable, but to be a lurking variable that causes, that had an effect on the results of the study, it would have to affect both the development of that tumor and whether or not they had decided to use cell phones, right? So, I'm having trouble thinking of one, but in a case control study, it's almost impossible to control for lurking variables. So, but another problem with establishing causation, how do we know when that tumor started and when they started their cell phone use? It's a benign tumor. They're probably very slowly growing. That tumor might have been growing for 15 years, and they bought a cell phone 10 years ago. Right? So you can't establish it's called a temporal relationship. Temporal meaning time through time, that one occurred before the other. Whereas a cohort study can do that. A randomized experiment can do that, but a case control study cannot do that. All right, that's all the time we have. So you will have 4.1 homework due Monday night by midnight. Have a great weekend. It's supposed to be really nice out, so